Oh, Kira, I have your breakfast from Blue. She brought you this.
Always
I know.
You're always
The best of friends.
dedicated to Chick-fil-A.
I do.
It's very.
What?
Do you think I could get a
Mr. Renner, can I go by?
what is?
Yes, can you do it after the?
Beef
Yeah.
Duke
They're just front and back.
That's my whole, like all of our birthday presents right now are white gold. So I'm trying to add to everything I have. I also don't like
All right, you'll notice your notes today are just a little front and a back, so let's do it. Okay, multiply or vectors can be multiplied with constants.
Oh.
Okay, which is basically it's called a scalar. Oops, I cannot spell. It's called scalar in like vector land, if you will. Okay, but you're only allowed to multiply vectors with single numbers. You cannot multiply a vector with another vector. That doesn't make sense. Okay, however, thank you. Thank you. Oh, hey, are you going down to Miss Clay's office? Can you bring her this orange sheet from me? Thank you so much. Okay. Okay, so you can multiply vectors by a number, but when it comes to adding, you can only add vectors with other vectors. Okay, so let's say you're doing the first one. You have 2, 4, this is the first vector, plus 3 times 3, 1. You're going to follow the same order of operations that you would do with numbers. You're going to do PEMDAS. So the M means multiply first. Okay, Nick. That's okay. Okay, so remember, we're going to multiply first, then add second. So I'm going to take the 3 from the outside. I'm going to distribute it into here. So what is my 3, 1 when I multiply it by 3? Okay, so what's 3 times 3? 9. And then what about 3 times 1?
3.
3. Very good. Okay, then from there, when you're adding, you're going to put the 2 x's together and then the 2 y's together. So my first x is a 2. My second x is a 9. What's 2 plus 9?
4.
11. Then I'm going to add my 2 y's together. I have a 4 and a 3. 4 plus 3 is 7. Okay, next one. What multiplier or scalar do I need to do first?
Half.
The half. Take both of these numbers, cut them in half. So my 20 is now a 10. My minus 8 is now a minus 4. And then remember, I'm adding that to 5, 2. Okay, then remember, when you're adding, the x's go together, the y's go together. So what are my 2 x numbers? Okay, 5 and 10 is going to give me a 15. And then my y's, add them up in the calculator if you need to. What is 2 plus -4? -2. Very good. Okay, then remember, the way that you denote that this is a vector and not like an ordered pair is that you're using the pointy brackets. Okay. All right, one more like that. Take a look at the next one. What's my multiplier number? -2. I'm going to multiply that into the 5 and the 8. -2 times 5 is a -10. -2 times 8 is a -16. Okay, now this is really important. Because you push the negative into the vector, you are now adding it with the 3, 2. So this is not a minus anymore because you pushed the minus into the horizontal and vertical components. Then from there, you're going to add them up. In your calculator, add 3 and -10, -7. And then add the 2 and the -16. -14, perfect.
So like whenever you get to that second stage, it's always adding.
Correct, because if there was a minus in the middle, you would have pushed it into the vector. Okay, Remember, A is the horizontal change. So I've been kind of lazy in calling it an X. Okay, but remember the technical term for that is the horizontal change. And then V is the vertical change. Okay, there are two ways for you to write vectors. The first one you already know how to do. A comma B, put it in the pointy brackets. Okay, there's a second version of that where it's called unit vectors. And it's very stupid, but it's also very easy. So what you're going to do is, whatever your horizontal change is or your X, you're going to group it with a vector I. And then whatever your vertical change is, you're going to group it with a vector J. So here's what I mean by that. Do you see this vector right here? Okay, negative 3 comma 4. You're going to do negative 3I plus 4J. Okay, then to turn the I and the J into vectors, you're just going to give it the little arrow symbol. So you would just go bleep, bleep, like that. And then you're done. Okay, so you'll notice this is a different representation of vectors, but really it's kind of the same. It's an I and a J, and then it's like a little arrow, but you only draw the top half of it. Okay? All right, look at the second one. My vector is 6 comma 2. Then I would do 6I plus 2J. And then after I've written it, I'll just put the little caps on to show that they're vectors. Okay, but there's no funny business with the I and J version. Everything still works the same. It's just how you write it. Okay, so let's come down to the next one and let's do 2 examples. So let's say vector U is this. Vector V is this. And I want to find 2U plus 5V. Then you're going to write 2U plus 5V. And then into those parentheses, you're going to insert vector U and vector V. But you're going to do it in I's and J's instead of the pointy brackets. So this is a 3I plus 2J. This is a negative I plus 6J. And then remember what I said, no funny business. You still do it in the same order. So what's my first step? Multiplying or adding? Multiplying. I'm going to times a 2 into the first one. So my 3I is now going to be a 6I. And then 2 times 2J, now that's a 4J. What's my multiplier into the second vector? The 5, and I think it was a plus 5, right? So then I'll times the 5 by the minus I, now it's a minus 5I. And then 5 times 6J, that's a 30J. And then from there, remember, just like I would add the X's together and then add the Y's together, now I'm going to add the I's together and the J's together, but it's basically the same process. Okay, so a 6I take away 5I would leave me with 1I. 4J plus 30J would leave me with 34J. And then remember, technically you should put those little caps on those I and J's to show that it's unit vector form.
Oh, why is it 1 to 6 if they can both leave 5?
Yeah. All right, take a look at the next one. This time I want U minus 2V. So I'm going to put blank minus 2 blank. And then occasionally on your homework, be a little bit careful about this. Sometimes they'll give you the U and the V in the wrong order. So just make sure you're paying attention. That like if this is a U, I got to put the 4I plus J in that spot. Okay. And then for my second one, I have a 3I minus 2J. I'm going to put that there. Then remember, distribute first, combine like terms second. Now, for the first parentheses, if there's nothing outside it, what do? What could I put there if I want? A 1. But is a times 1 going to change anything? No. So I'm basically going to keep this the same because there's nothing in front. So the 4I plus J, that's going to stay the same. Am I timesing in a 2 to the second parentheses?
Yes.
And a minus, right? Remember, you want to bring both of them in. So minus 2 times 6, that gives me a negative 6i. And then what about minus 2 times minus 2j? Minus 2 times minus 2 plus 4j. Okay, then from there, you're ready to add up your like terms. So 4i take away 6i gives me negative 2i. And then how many j's does this one count as if there's not a number there? 1. So if I do 1j plus 4j, how many altogether? 5j. Okay. All right, go ahead and turn the page. We're on the back side. Okay, my goal is for us to not have to do all of these because a lot of this is what we did last time. Okay, so look at your vector. It says 3i minus 5j. Okay, you should know that that is the same as 3 comma negative 5. You should also know how to graph it. Remember, I can start the vector wherever I want, but if possible, I'm going to start it at the origin. So put your little dot right here. This is the tail. And then I'm going to map out where 3, negative 5 would go. So 1, 2, 3. 1, 2, 3, 4, 5. And then draw your vector. So it says, plot the vector on the right, check. Write the components of the vector, check. We did it right there. Okay, next it says to find the magnitude. Do you remember how to do that from last class? Maybe not. Okay, put your bars like this. That means the magnitude of u, the little double bars. And remember, magnitude is just how long the vector is. This is where you're going to do a squared plus b squared, then take the square root. Okay, also remember, no negatives when you're calculating length. So I'm going to do 3 squared plus 5 squared. And then I'm going to take the square root of that. Now remember, when you put it in the calculator, don't type the square root. Just do the numbers part in the middle. So 3 squared plus 5 squared, that gives me 34. Then my answer is the square root of 34. And remember, that's the length of how long the arrow that you drew is. Like take out a perfect square. You don't have to do that. You should know how, but you don't have to. Okay, last thing for that question is direction. Remember that direction is tan theta equals y over x. Which one is my y? The 3 or the 5? 5 over 3. And then remember to solve. How do I get rid of the tan in the calculator? Tan negative 1 or inverse tan on your calculator. So second tan here, 5 over 3. And you should get 59 degrees. Now, quick question. 59 degrees, is that the final answer or no? No, that is called the reference angle. And remember, once you know the reference angle, that tells you how many degrees are in this part of the triangle. So I'm going to highlight it. This is 59 degrees. Okay, but remember, that is not where you measure direction from. Direction has to be measured starting at the positive x-axis, and you have to rotate this way. So remember, we did a little formula chart last time for you to find direction. Does anyone happen to remember the formula for this quadrant? 360 minus. Okay, then remember in quadrant 1, theta is just your answer. This one's 180 minus theta. This one's 180 plus theta. Okay, so then if 59 is my reference angle, then 360 minus 59 means 301 is my direction. But remember, once you know the reference angle, you're using your quadrants to pick your last formula. Okay? All right, we're gonna do one more question and then we're done with notes. Let's do the very last one, please. Okay, so it says, let vector v have the initial point 4, -7 and the terminal point 0, -2. So on your computer, you would start at 4, -7, and you would click and drag to 0, -2. Okay, remember, you have to start at the initial point and click and drag to the terminal point. Then in your delta math, it'll let you click the vector and just slide it to the middle. Now, we're not going to be able to do that because we're on paper. So instead, we're going to count the X and Y and then redraw it right here. So how many do I have to go to the left for the arrow? How many boxes?
4.
4, and then how many up? 1, 2, 3, 4, 5. So it'd be -4, comma. And then I'm going to redraw it here. -4, 5. Okay, but remember what we said, a vector, as long as it's the right direction and the right length, it doesn't matter where you graph it. Okay, so this vector and this vector are identical. Okay, then it says to find the magnitude. Remember, magnitude is going to be a squared plus b squared, then take the square root. So I'm going to do 4 squared plus 5 squared, then take the square root. 4 squared plus 5 squared gives me 41. And if 41 was a perfect square, I would do it, but it's not. Then for direction, what's my formula? Okay, tan theta equals y over x. I'm going to give you the formulas here in the middle. Okay, but then for this question, my tan theta is going to equal 5 over. Okay, and then remember, negatives don't count for either one of those. Okay, then in your calculator, you're going to do second tan 5 over 4. So that's 51 degrees. Is that my final answer? No, 51 degrees is from here to here. But remember that I measured direction from here all the way around. So what's my formula for direction in this quadrant? 180 minus 51. So 180 minus 51, that gives me 129. Okay, but you do have to find your reference angle to then be able to go on to the direction. Okay, so in the middle, if you haven't already, I want you to write your two formulas. Remember, magnitude and direction. Okay, then I'll put then direction chart, which is theta 180 minus 180 plus 360 minus. Okay, that way you kind of have everything you need in that one section. Okay. All right, that should be good for you to do your homework. Maybe we'll do like one together and then I'll let you work for the rest of class on your own. Go ahead and pull out your computers. Let's log into Delta Math, please. Oh, is it still hidden? Do you want scratch paper? No. Can you use scratch paper? Here, you can separate it. No. Only paper over here. Paper over here. What do you say? Oh, that's fine. Y'all need paper? Y'all need paper? Here you go. Sure.